Okay, so next numerical test, the second one, TEST-3E, Class 9 Science, Chapter 3, Atoms and Molecules. All these questions here, 3.4, 5, 1, 2, all on your textbook, page 44 you will find. Now in the previous video, the one ahead of this, I think 6, we have already solved and shown 3.4. But today also in this question, some questions based on the same one is going to come. So go and refer that example 3.4 solving part in the previous video. We'll not be repeating here. We'll go straight to 3.5. So I've written the question also on the board to make it easy for us. Exactly like textbook, example 3.5. Here we have to calculate the number of particles. Now particles means either atoms or molecules. We have to figure it out ourselves, okay, in each of the following. So let us take the first one. There are 3 of them, I think. First one, 46 gram of Na atom means sodium atoms. You have to calculate the number from mass. Like yesterday in the previous video, we have to remember this formula here. 1 mole equal to gram atomic mass or gram molecular mass, which will be equal to having Avogadro number of particles 6.022 into 10 to the power 23 atoms if it's atoms, or molecules if it's molecule. They are saying number from number from mass. So we know number of particles is this one. So this one and this one here, mass. Number from mass, very clearly. So these 2 portions of the formula we're going to have to use, not the mole. So you have to find the number, calculate the number. So let us put a number, atoms or on the right side and mass on the left, which is not a hard and fast rule, but most of us find it easy to do it here. And just start directly. Gram. Now we have to sort out whether it is atomic or molecular. Very clearly, question itself told you atoms, so we can write here atomic very confidently. Even if they didn't say atom, we can figure out like we have done in previous video. If at the back of that substance there is no number, means it's 1. So 1 atom is atomic mass. Anything more than 1 will be molecular mass. Okay. So gram atomic mass of this case here Na. So let us calculate that. We know now how to calculate by using the values given. So at the back, no number means 1 sodium atom, and on page 37 each sodium atom weighs 23 U. So we change that to gram. Same number we take because this is gram atomic mass. So 1 into 23 will be 23 grams. This is the gram atomic mass of sodium, 23 grams. So this one we know by formula, means we're taking this formula here. Gram atomic mass is equal to Avogadro particles, because we have to calculate the mass. Avogadro particle is equal to, you have to calculate the number of particles in each case. So we know that this gram atomic mass contains Avogadro number of particles. So we write this one same. So we're writing this from formula, okay, not from the question. 6.022, this 2 part from here, from this formula. 10 to the power 23, and because we took atomic mass, this also should be indicated as atoms. So the particles here are atoms in this question. So therefore, like yesterday in the previous video, mango method, I'll not go back there. 23 gram max contains this many atoms. So how about 1 gram? Because if you find for 1 gram, we can find for any other, right? For 46 very easily. So 1 gram of Na atom, okay, will be equal to how many particles? This right side, like the mango method, divided by this number, isn't it? Like yesterday we did. And right side the unit is atoms, so I'll write here atoms. Left side the unit is gram, so gram should remain on left side, should not come on right side. That means an atom should remain on left side, also right side, and should not come on the left side. Okay. Therefore, if 1 gram is found, you can find for any other grams. So question is asking for 46 grams, so we write here 46 gram of Na atoms or sodium atom, in other words, contain, quite easy I think, same number you write, 6.022 into 10 to the power 23. I'm just copying from here and here also, just same thing, and then multiply that to whatever number you're trying to find grams here. But we should not write a gram here. Right side unit is atoms, left side gram should remain there. 23 ones are 23, 23 twos are 46. We know that. So we get here a number. So here, multiply this number to this. This power don't touch. 2 twos are 4. Again, 2 twos are 4. 2 zeros are 0. And 2 sixes are 12. 1, 2, 3 decimal places. So it will jump left. 1, 2, and 3. 12.044 into 10 to the power 23. Atoms will be there in 46 gram sodium you take. Then this many particles you will be able to find. So this can be your answer. No harm. But usually answer is expressed in standard form. So you bring this decimal standard form means right after the first digit here, between 1 and 2. So when decimal comes after the first digit from the left, that is called standard form. In order to shift this decimal to the left, you have to compensate that by putting a 10, because once you multiply 10, it will become original. So this one here into 10 to the power, same thing, 23. I'm just showing the steps. From the next one, I'll just do direct, okay? This one is your thing, but this cannot be in the final form. Now you write the final answer here. That will be equal to, now 1.02044, we want to write that, okay, into, okay, then 1 power plus 23 power is 10 to the power 24 atoms. So this can be your answer. Or you can also write it one more step, 1.0, go to third place is enough, 1.02, and third place is 5 or more than 5, this will increase, but this is 0, so just keep it there. Like this also, usually up to second place the answer is given by checking the third place for approximation, and that usually most textbook write like that. So you can write like that is your final answer. This or even this can be your answer. I explained, so I took extra step here. So please keep that in your mind. So this is, let me write it properly. So you can write in the second place means third place, check 5 or more than 5, this will increase, but this is 0, so remain same, 2, then 10 to the power 24 atoms. This is the best answer I would choose, okay, standard form. So that's your first answer, okay, your first answer. Now we'll go to the next question, subheading number 2. Let me write the question for us so we can easily see on the board and do easily. Number 2 is 8 grams of O2 molecules. So remember that 8 grams of O2 molecules. That's what the question is saying this time. This time you have to bracket, in the question is given number of molecules from mass. You have to calculate the number of molecules. That means the particles this times are molecules. Just before this it was atom, no? Number of molecules you have to calculate from mass. Still same as the first one, number from mass. So we have to use the same formula, number of atoms or molecules, and gram molecular mass, mass and number. So just like we did just now, you write here gram, and very clearly it's molecule. So molecular mass of O2 molecules. They have even written molecules. Even if they didn't tell you it's molecule, it's quite easy to sort it out. Make it longer because you have to calculate that. Better to calculate right from here. Now, at the back of O, what is the number? Yes, 2. That means 2 means more than one atom, like this. So it's a molecule. If it is like this, it would have been atom, only one, right? More than one atom, same type, different type, it's a molecule. So gram molecular mass is always equal to this Avogadro number of particles. So 6.022 into 10 to the power 23 molecules. So we should not write atoms this time. That many oxygen gas molecules or 2 molecules. Okay, next, calculate the gram molecular mass. Very easy, we have been learning that. At the back of O is 2, so there are 2 oxygen atoms making 1 molecule into, this is in front is 1, no? 1 molecule. 1 oxygen is 16U on page 37. You check on your text there. Page 37, there is a table towards the right corner, top right corner. So U will change to G because it's gram molecular mass. That will be equal to 32 grams. 16 2s are 32. So 32 gram contains this many molecules. So like we have been doing, let us find out for 1 gram of O2 molecule will contain how many molecules then. Let us first calculate that for 1 gram. That will be this number, like the mango method we've done in the previous video, sufficiently taking time, so we'll just avoid that explanation today, divided by this 32. Then right unit is molecules, so that molecules you'll write. This gram is left side unit, so we should not bring it on the right side. Let the gram remain on the left, molecules remain on the right. Therefore, question is asking for 8 grams, so you write here 8 grams of O2 molecules. Simple, 6.022 into 10 to the power 23 divided by 32. Same thing, you write molecules. And then multiply to this number here, 8. But don't bring the gram. Gram is on the left side, that is molecules. Now 8 ones are 8, 8 fours are 32, right? Now we know this will surely go with 4, right? Because 4 is going to exactly divide any number. If the digits run out also, you keep on putting 0 back, you will find it, the ending point of division. 4 ones are 4, then here 4 ones are 4, 6 is there. So 2 remain there. That 2 will go in front of the 0 after decimal here. 24 5s are 20. Then no remainder, 2. Now when cancelling, we cannot take 2 digits at a time. Take 2 first. That is lesser than the divisor we're using 4. So in such case, we need to put 0 first to combine them with the next one, 2, 2. 4 5s are, please note that 4 5s are 20. Let me write this a little bit above so there is no confusion. Now, 4 5s are 20. Then 2 in hand again. Because of this decimal, 0 could go back to the next to remainder because no more digits. 24 5s are 20. So our answer here is 1.5055, okay, 55 into 10 to the power 23 molecules. This can be your answer, no harm. But the best answer in most textbook is given in this format in the second place by going to third place. So 1.5. Then you check the third place. 1 decimal, first, second, third place. Third place is 5 or more than 5. Here 5. So this will increase by 1. 0 plus 1, 1. Go only up to second place by observing, checking the third place. That's called approximation. Up to third place, but taking decimal to the second place. And then 10 to the power 23 molecules. This is the most accepted form of answer up to the second place by watching the third place. This is your answer, okay? You can leave this one as also an answer. It won't be so strict with most teachers. Now next, let us go to the third one. And the third one is subheading 3. Let me read the question for us. 0.1 mole of carbon. So this time slightly different question. 0.1 mole of carbon. 0.1 mole of carbon atoms. Clearly they have mentioned even atoms. Even if they have none, we can easily figure out. We learned that, right? This time from bracket, you have to calculate the number of atoms. Number means number of atoms from given moles, so from the mole. So the formula is going to change. From given mole. That means you have to calculate the number, this one, by using the mole, this one. So we shouldn't be using this mass now, this time, these two formula. To calculate the number, so that means number, let it be on the right side. Most of us are comfortable putting the quantity we want to find out on the right, right? So number, they told you to find number, so let us put it on the right, which is this. Calculate the number from mole. So 1 mole, so just start that. 1 mole of, this one is from the formula. Now the rest you can go and check off. This one same as in the question. Carbon atoms is equal to, we have to use mole and number. So this one, 6.022 into 10 to the power 23. Atom or molecule? Surely atoms here, atom. Now, therefore, 0.1. 1 is there means very easy, 0.1 mole of carbon atoms. This is what the question is asking. So it's such a simple case of, once we know what is 1 mole, 0.1 mole will be, right side you need this atoms, so just write it, multiply to this number, 0.1. But don't bring the mole. Mole is the left unit this time, okay? Right unit atom, right remain on right, left unit remain on left, okay, the rule. Now forget about the 1 and multiply to this, it will become same number, 6022. Don't write the decimal now. Now here, 1, 2, 3 decimal and 1 here, 4. So 1, 2, 3, 4 decimal will shift here. 0 point, like this. So instead of doing that, the best way is, this is already in standard form. As we say, standard form is decimal after first digit. 6, the first digit is not. So don't disturb that. And then write this one, 10 to the power 23 atoms. And by common sense also, we know this is 1 divided by 10. Decimal move left now because of this 0, and get this one. 0.1 is 10. See here, 0.1 is 1 by 10. 0.01, 2 places means 1 by 100. 0.001 means 1 by 1000. Common sense. So this 10 to the power 1 cancel, and 1 power gone means 23 minus 1 power 22 left. So your answer here will be 6.022 into 10 to the power 22 atoms. This many atoms, okay, 6.022 standard form. So into 10 to the power 22 atoms. So that is the particles here. That is 3.5 is finished. Now 2 more questions before this test portion complete. So let us go to that one. Okay, let me read the question for us. Question number 1. Next year, see, page 44. Textbook, page 44. Okay, let me read. It's quite simple. If 1 mole, towards the bottom of the text, page 44, blue letters. If 1 mole of carbon atoms weigh 12 grams, what is the mass in grams of 1 atom? So, since, question is clearly since, 1 mole of, just look into the text and read the same language, 1 mole of carbon atoms, okay, weigh 12 grams. Weigh, W-E-I-G-H, weigh equal to 12 grams means body, how heavy it is. Therefore, that is, so we know the formula. We can transfer this 1 mole, that is, question is asking, what is the mass in grams of 1 atom? But this is in mole, not atom. So connect the mole to the atoms, number of atoms. 1 mole is same as this one. So replace the 1 mole by 6.022 and 10 to the power 23 atoms. In other words, this many atoms is 1 mole. So that atoms of carbon weigh 12, because this is the same substance. No, it's mole is changed to number of atoms. Only 1 mole contains this many atoms. So once you change atom, why? Because they are asking for 1 atom's mass. So just write here 1 atom of carbon weight equal to, like the mango method, 12 divided by this one, 6 point, right side by left side. No, when we are finding for 1. Mango method, do you remember? Yes. So here, let's do here 12 divided by this number, 6.022 into 10 to the power 23. Okay, this one 12, this much grams. So this is your answer. Now let us keep it simple so that we don't get confused. Let us divide this 2 parts. Okay, 12 is divided by, but before that, let us remove the decimals from the denominator, because it's easier to deal that way, right? So here 12 divided by 6.022 into 10 to the power 23, this much gram, multiply that to how many decimal? 1, 2, 3 places. So 1, 2, 3 zeros will remove it to the right. Whatever is down, put it up there. So this will be, just keep it there, and then just write 12 and 1, 2, 3 zeros, 1, 2, 3 zeros, divided by here 1, 2, 3. So moving right 2 and 3. So at the back of 2 means no more decimals, 6, 0, 2, 2. And then into 10 to the power 23, this much grams. Gram is on a numerator. Then we can cancel here. Okay, so 10 to the power 23. Okay, just keep it like that. Then we can divide these 2. Here 6 is going with 2, I think. So 2 3s are 6, 0, 1, 1. 2 6s are 12, 0, 0, 0, 6,000. So write this part here. 6,000 is divided by 3011 into, and then 10 to the power 23 is plus power. So bring it to the numerator means it becomes 10 to the power minus 23. grams. Chivit like that. Okay. Then you divide this one. So 3011 divides 6000. Do that division. So 1 will go because 2 will be 12,000 or 6,000 more than that. So 13011. So here 9 remain. 8, 9 minus 1, 8, and 9 remain. 1 is taken, so 5 minus 3, 2. Then here, no more digits of point and 0. Then 9 will go, so 9 ones are 9, 9 ones are 9, 9 zeros are 0, 9 threes are 27. That's why we did it. 10 minus 9, 1. And 1 is gone, 80 minus 9, 9. 1 is taken, so 7 is left. Nothing is taken from here. From here only it is taken there, so 9 minus 7, 2. Again, see, 27910 means point is there, so I can put the 0. And then 27, this is still going to go 9. And same number, no need to do, 27099. Then one more place, third place you go, 10 minus 9, 1. 10 minus 9, 1. And then 1 is taken, so 8. Then 0 here. Then 2 will be going, so 2 means 2 ones are 2, 2, 0, 2 threes are 6, 6022. So up to third place is enough. So once you do that, what you do is, you write your answer here. This 2 divided is 1.992. Normally we go like that up to third place. Into 10 to the power minus 23 gram. 1 atom mass, so small. Then you take approximation up to second place by watching the third place. Less than 5, so no change will be there. 1.99 into 10 to the power minus 23 grams. Your answer is also in standard form, right? 1.99 into 10 to the power minus 23. So small. It is going to be denominator divide means 0.00000. Such small mass it will be. So that is the first answer. Okay. One more question before we end this portion. Question number 2, textbook, page 44. Not hard, just listen carefully. Okay. Pause the video and write it down if necessary and come back and replay and do, okay, those parts. I think by now you know what you're supposed to do, so just follow that. Now, question number 2, let me read that for us. Which has more number of atoms, 100 grams of sodium or 100 grams of iron, do you think? The question is saying. Given mass also, sodium 1, sodium is 23U, iron Fe is 56, that is also given. Normally the mass is given in the question, okay? So here, let us take the case 1. That is the case of 100 grams of sodium. Let's find out for 100 grams of sodium. Symbol is Na, so let me just write it in short. Now we know that gram, okay, atomic mass of sodium, because Na means only one atom. That is 1 into 23, G is equal to 23 grams. This formula we're using, okay, this gram mass, always contains 6.022 into 10 to the power 23 atoms of sodium, atoms. So we are using that formula. We need to use these atoms and mass, because they are saying 100 grams contain more atom, 100 gram means mass, more atom or less, 100 gram lesser than 100 grams of iron. So this is the one. So let us find out for one atom. Therefore, you write here 1 gram of Na. 23 gram is this much. So 1 gram, 6.022 into 10 to the power 23 divided by this 23 atoms it will contain. So we have to find for 100 grams. So right here 100 grams of Na will be 6.022 into 10 to the power 23 by here 23 atoms. Just write that one, the right side you need. Multiply to this 100 number here. But we shouldn't bring the gram, because gram is the left side you need. What you need is on the left side can never be shifted to the right. Okay, and what you need on the right side is there should not disturb the left also. So here, this many. Now let us do this multiplication. If you multiply this to this decimal, decimal move 2 place to right, so it will become 602.2. See 1 and 2 because of this 20. Divided by 23. Let us write that part. And just separate, not need to separate also, but if you want, you do like that. Atoms. Now let us divide this part and see, okay? And bring it to standard form. So 602 is divided 0.3 or 0.2. 602.2 is divided by 23. 23 2s are 46. So 4 remain. 5 minus 4, 1. Then the next number is 2, so you can bring down that one. So you can just write that, and then 6 is going, I think 6 3s are 18, 6 to the 12, yes, so 4 remainders, 4 remainder. Okay, so 12 minus, yes, so next point here means we shouldn't put here, okay, and then bring down the next one. 2 will be too much, so 1 is going 23. Now this is 9, 3 minus 2, 1. So point means 1, 0 you can put. So 26.1 and 8 will go, I think. So 8 3s are 24, 8 2s are 16, 17, 18. So you can stop there, okay? Because we're going to bring this decimal here means already 3 places are there. Even though there are 2 now, we're going to bring here because of want to maintain standard form. No? So this 2 will give you 26.18. It's divided into 10 to the power 23 atoms. So write this in standard form. There will be decimal come here. Then 2.61, okay, 2.618 into 10. Then only you can bring there. So into 10 means it will go here. And then I shown you in the previous sum. Right? So 1 plus 23 is, it will increase 24, right? So 24, this many atoms. This is, let us write in standard form once more. So finally here, this is previous sum, so you can just avoid that. Now here, that will be finally 2.62, because third place is 5 or more than 5, then second place usually standard form digit, and second place, that's the most accepted form of the answer, 24 atoms. Let us keep this one as equation 1, okay. Now let's go to case 2. Case 2 is 100 grams of iron. Now we'll just shorten this one, gram atomic mass of iron. If you look into your text, 1 iron is given in the bracket in the question itself, 56 grams. So this will be 56 gram. I'm just following the same thing. Now 1 gram of iron. So you write your iron instead of that one. Divided by, now instead of 23, it will be 56. And then here will be 56. But they are asking for the same gram, 100 grams. Look into the question. So you'll multiply by the same number, 100. Now, right up to here, okay? I'm waiting for you. I'll post the video the best way. Now, this 20, shift this decimal 1, 2, so 602.2 divided by 56. You just separate it. No need to separate also actually, but for easy sake of calculation, and then one more can go, I think, so it becomes easier to divide. 2 is going, 2 2s are 4, 1, 2 8s are 16, so 2 3s are 6, 0, 1.21. So this 301.1 is divided by 28. This is going to be easier. So 28 ones are 28, 2 in hand, 1. Now you have to be very careful with this division, okay? So here, after you bring one digit, still it is smaller, means you cannot bring the next one. Put a point and then put a 0, 1. Still not going, see, 2 remainder, brought 1, still smaller, means I have to first put 0, and whatever is there after that, put point. Then only I can bring down the next one, this one. So 10 point, and then 7 is going, I think. So 7, 8s are 56, 7 2s are 14, 15, 16, 17, 18, 19. So this remain is 5. 10 minus 9 is 1. 1 is already taken, so no more. And point means 1, 0 I can put. And then 28, okay, 5 is going, I think. So 5 8s are 40, 5 2s are 10, 11, 12, 13, 14, yes. So that is going to go. You can stop there because 2 places, but still you're going to bring here, so it's going to be 3 places. Standard form you're going to do. That is enough. So you write here, that will be equal to 10.75 into 10 to the power 23 atoms. And then you convert this one to standard form. See here, bring it here. 1.075. Then to shift 1 place left, you have to multiply by 1 0 extra, 10. They'll add to this 23 power, become 10 to the power 24 atoms. Last step here, approximation, standard form already. Third place 5 or more than 5, this will increase, so 108. So this is the number of atoms in 100 grams of iron. So this is equation number 2. Now compare 1 and 2. 100 grams of iron contain 1.08 10 to the power 24. This is same, 10 to the power 24. This is the sodium, 24, but this part you compare. 2.62 is greater than 1.08. This is same, na? 10 to the power 24. Compare, then this is much more. So the number of sodium atoms is more. So you write the final answer. The final answer means your final sentence after these two. So you write here, using 1 and 2 or comparing equations 1 and 2, you can write your final answer. 100 grams of Na has, question is saying which has more number of atoms, has more number of atoms than the same mass, that is 100 grams of iron. So that is your answer. That concludes this test part. Go and give that test 3E. It's identical. Every question number is slightly changed, so it will really make you practice and it's going to be fun. It's not hard. Okay.